Now, this question, it's a very typical type of optimization question because of the design. Now, for the earlier problems, we didn't actually find out the graph, but we easily found out the minimum and maximum, right? And we, would say, oh, that's how you optimize the cost. That's how you optimize the area. Now, so here we have a little we have a little setting right here. We have a piece of wire that it's 40 centimeters long. Okay, and we're going to cut into two pieces. One piece will be bent to a circle, and the other one is going to be a square. Okay, so the wire of these two must add up to 40. Okay, so before we do anything, I think we should be able to write something down, and that is 40 centimeters is equal to 2 by r, and 4s, circumference and the perimeter of the square. They should all add up to 40. Okay, that's something that we can write. It's a true statement. Is it going to be useful? We will see, but that's something that we can definitely write for sure. Now, it says what? Find the radius of the circle and the length of the side of the square so that the total area is a minimum or a maximum. Okay, so now, so we have the area, right? So we want to find the area of both to be a minimum or a maximum. So what does it mean? Well, that means we're going to have the area of the circle, which is pi r squared, and the minimum of the the area of the square, which is s squared. That would be the area altogether. Now, we are trying to find the minimum area and the maximum area. So let's tackle the minimum first. Okay, like I said before, it's always a good idea to draw a pair of axes. And we say, hey, can you go ahead and find the area? Sure, we can find the area, the minimum and the maximum area. But what is the horizontal axis? Well, you have two choices. You can put R, you can put S. Okay? Which one should we do? Technically, it doesn't really matter, but that's one better than the other because of the ease of presenting it. Do you know? What would be the better choice? Is it radius or is it the side length of the square? But then why? Why is the side length of the square better? Well, can the length of the square be infinitely long in this case? We say no. There's a maximum length. It could be. What's the maximum length? For each side of the circle. Be 10. And this is where I want to add a little bit of a explanation right here. So this is the side length, right, of the square. So if the side length is equal to 0, that means we don't have any square, and it is all circle. Okay? And if the side length is 10, then we have all square and no circle. Okay, that's what it means. How we are putting the length of the wire to use. So far, so good? Yes? All right. So if S is what we would prefer to work with, okay, if S is what we want to use, then what we must do is to solve for R so that we can substitute the thing into R. So how can we solve for R? So R will be 40 minus 4S over 2 pi. Okay? Or if you want it to be a little bit simpler, we can reduce it by 2, 20 minus 2s over pi. Okay? And then we can go ahead and substitute in to the area equation. So pi 20 minus 2s over pi. Okay, so now essentially we have a function of area in terms of s. So we have 20 minus 2s square over pi. So this pi over pi square, which is be a pi remaining. So the area equation would be something like this. So far, so good? Okay. Now I could multiply out the 20 minus 2s square. I think I'm going to leave it like this. I think it's okay to just leave it like this, and then we can just do the chain rule afterwards. So we have 2 over pi times 20 minus 2s, and then times negative 2 as the derivative of the inside, and then plus 2s. So if you multiply all out, so negative 4 over pi, 20 minus 2s plus 2s. Oh, sorry, a prime of s. 80 over pi plus 8s over pi plus 2s. Okay? And we will try to set it equal to 0. Okay? So what you would get, s equals to 2 plus 8 over pi, and this would be 80 over pi right here. You may go ahead and do this. And the reason why we'll do this, because the pi could get canceled out. So so what you would have is that s is equal to 80 times 2 pi plus 8. Wait a second. This would be a bit too much. Oh, no, sorry, my bad. Divide, not multiply, divide. Yes, divide by this. Okay? So if you actually go ahead and put this into a calculator, so 80 divided by 2 pi plus 8, you would get a value of approximately 5.6 meters. Okay? So now, so that's how you get the critical value. Is it a minimum? Is it a maximum? We don't know yet, actually. So how can we know if it's a maximum or minimum? Okay. Now, so we know that at around 5.6, there is a very special point. Is the minimum or maximum? We shall see. But how do we see? Let me go ahead and bring you to this point right here. If I ask you, what function is this? Can you see what function it is? a function that we have learned in the past. Since s is the variable, the pi in the denominator is just a coefficient. So if you look carefully, this would become 4s squared, right? Positive 4s squared. This is another s squared. So that means we have a quadratic. We have a positive quadratic equation. So that means if we get a critical value, then we have a minimum at 5.6. Okay? But now, we have a very interesting situation. I think we can go ahead and answer part A. Part A would be, yeah, so the area would be the minimum when s is equal to 5.6, and then you can go ahead and use this to calculate your radius. That's cool. That's done. Okay. Maybe we can finish that first. And that is, what is it? So r is equal to 20 minus 2s over pi. So 20 minus 2 times 5.6 over pi. So r is equal to 20 minus 2 times 5.6. Oops, sorry. 20 minus 2 times 5.6 divided by pi. So that would be a 2.8. Okay, cool. We have a circle with a radius of 2.8 meters, with a square with a length of 5.6 meters. Wonderful. Okay. So far, so good. That's the part A. Now, what is challenging that you should anticipate is this. Usually, if we ask this question, we may not ask you for both on the test because of time limitation. And if we have to pick one to ask, we usually ask you for the maximum. And why do we ask you for the maximum? Is because, well, are we going to have a maximum? Now, the graph is going to be like this, right? It's a quadratic. So is the maximum, is the absolute maximum on the left when the side length is 0, or is the absolute maximum when the side length is at 10? Now, there's an easy way to figure this one out based on what you learned back in algebra 2. There's a very simple feature about quadratics. What do we know about quadratic functions? If we know that this is the vertex, right? This is the minimum. We know that quadratic functions are always symmetrical. And since there's more space here than over here, if you need to draw or hypothesize some values, then this has to be the case. Okay, or maybe I can draw a better parabola like this. Yeah, it'd be more like this. Okay. Now, of course, when you are going to answer the question of the maximum, you will do the following. You will say, well, 5.6 is the minimum. So you would do the candidates test. You would actually go ahead and show your work for A of 0 and A of 10, because if the minimum is in the middle, then the maximum, the absolute maximum, would have to be from either ends of the interval. And we say, oh, okay. So when the side length is equal to 0, so we have what? This is the original equation of A of S, right? So 20 minus 2 times 0 square over pi plus 0 square. And then we have 20 minus 2 times 10 square over pi plus 10 square. The second one would simply be 100 because when we have 10 for the side length, that means we don't have any circle. And when we have the side length at 0, that means we have all circle. So this would be 400 square over pi. And 400 over pi, not 400 square. 400 over pi, which is about 100 something, bigger than 100. So that's how we know that the maximum area is achieved when side length is equal to 0. And if side length is equal to 0, then you can go ahead and find out the radius. The radius would simply be 20 over pi, which is 6.4 meters. Okay. So if I were the teacher, I would definitely have this on the test because it really tests you how to think. Are you actively thinking about the graph? Are you considering the effective, the reasonable domain? Okay. Now, and for your horizontal axis, it is okay to use R instead of S. However, your effective domain could be a lot more uglier if you use radius. Okay, so that's why I use the side length of a square for the horizontal axis, because I can say, oh, it's going to be from 0 to 10 instead of some ugly decimal numbers for the radius. Good. Okay. So yeah, so make sure that you understand this kind of setup. And I've seen some other types of problems similar to this. You can do, I mean, the question could be like, oh, you have a circle, you have a square. It could also be a square and an equilateral triangle, you know, all kinds of shapes. And, but the concept, it's going to be very similar for all of these questions.